looking at the questions on the sample exam from Chapter 5. If you wish, you can pause the clip at each question and attempt it on your own. And I'm going to continue with the solution. So the first question, multiple choice number 22, is what is the range of the function of y equals f of x shown in the graph below? So here they have f of x graphed. It's a quadratic function of degree 2. That is a polynomial degree 2. You're looking at the range, so you're looking at what y values it will have. In this case, 2 is the y value, and anything greater than 2. So we will have y such that y is greater than y is greater than or equal to 2. Y belongs to a set of real numbers. In Chapter 5, quadratic functions are the only functions that has a set range. Other functions, like a linear function and a cubic function, will have a range of y belongs to a set of real numbers. What is the y-intercept of the graph of the function? This here we have a cubic function. It wants to know the y-intercept, and from the equation we can tell the y-intercept from the constant term. So here the constant term is 1. Now, this question, something similar as this could be asked. It could say, what is the end behavior? Or what is the leading coefficient? We have a leading coefficient here. And that helps us with the end behavior, telling us if it's increasing or decreasing function. Which graph best represents the function with the characteristics listed below? It has to have 3 x-intercepts, so let's first to see if that can cancel anything for us. Here we have 1, 2, 3 x-intercepts. In graph B we have 1, 2, 3 x-intercepts. In graph C we have 1, 2, and in graph D we have 1 and 2, and so C and D we can cancel out as they only have 2 x-intercepts. We need a graph now extending from quadrant 2 to quadrant 4, and the quadrants are 1, 2, 3, and 4, if you recall. So we have to go from quadrant 2 to quadrant 4. Looks to me like that will be A, as B will go from quadrant 3 to quadrant 1. And just a little side note here, if we have something going from quadrant 2 to quadrant 4, that would be a negative leading coefficient. And going from quadrant 3 to quadrant 1 would be a positive leading coefficient. Here we have, it says, given a table of a scatter plot and the curve of best fit of the polynomial f of x, what is the value of f of 5? So we're looking when x will be 5 based on the trend. And so here they have a table, and of course x equals 5 is not in the table here. We know it is between 12 and 24. We're going to use the trend, and if it's between 12 and 24, we can cancel out A and B. They're not options. If we look at x equals 5 and we go up to the trend, you could see that it crosses right here at 20. And so D will be the answer. This is a cubic regression function. So the example of what type of regression questions you could get. Here we have, which quadrants does the graph of f of x equals x cubed plus 3x squared subtract 4 extend? And so we're being asked for end behavior here of a function. And when you're asked for end behavior, you look at the leading coefficient. And the leading coefficient here is 1. It's positive. And so for cubics, if the leading coefficient is positive, it makes the shape of an N. So it go from quadrant 3 to quadrant 1. If it was a negative leading coefficient for a cubic, it would have a backwards end shape, which would go from quadrant 2 to quadrant 4. If it was a quadratic, if we had a quadratic equation here, an equation of degree 2, and it was a positive leading coefficient, this would be from quadrant 2 to quadrant 1, and a negative leading coefficient would be from quadrant 3 to quadrant 4. So this question could change in any way. Here we could put a quadratic or a linear function equation here, and you would have to answer the same type of question. This one here has a constant of -4, and that would mean that the y-intercept would be -4. So which function passes through the point 1 and -7? If it passes through the point 1 and -7, when you put 1 in for x and -7 in for y, it should satisfy the function. So for example, in A, we would have -1 cubed, subtract 3 times 1 squared, subtract 1, subtract 4. And of course, that does give us -7, so the answer would be A. It says sketch 2 possible graphs that are different, yet they both are cubic functions with negative leading coefficients and negative y-intercepts. So you have a negative leading coefficient, which makes a backwards end-shaped graph, and a negative y-intercept. Explain why the graphs you have sketched are different. So the first graph I will sketch will be one like this. Here we have a negative y-intercept, so that satisfies it. It is a negative leading coefficient of backwards end. And the second graph I will sketch will look something like this. And we still have a negative leading coefficient and a little loop right here. And so when we look here, how are they different? Well, the first graph has 3 x-intercepts. The second graph has 1 x-intercept. This graph will have 2 turning points. Whereas graph 2 has 0 turning points. Given the function f of x equals equals 2x to the power 3 plus 5x squared subtract 3x subtract 4, complete the table to describe the characteristics, the y-intercept, which is given to us by a constant of equation. And in this case, the y-intercept is -4, or the point 4, 0, and -4. The end behavior, which is given to us by the leading coefficient. And from left to right, it goes from, since it's a positive leading coefficient, we have a positive leading coefficient. We have it going from, the shape of the graph would look something like this, N-shaped graph. It goes from quadrant 3 to quadrant 1. The maximum possible number of x-intercepts for a cubic function which of degree 3 would have the maximum possible number of x-intercepts is 3. It doesn't have to have 3 x-intercepts, but the maximum is 3. Explain why the graph of this function is not a parabola. Well, it is of degree 3, where a parabola is a quadratic equation, is degree 2. So in summary, we have multiple choice number 22 to 27 on the public exam will be from Chapter 5, Polynomial Functions, and it's the constructed response item will be number 55. You have to be very careful here. You have to know the characteristics very well. You have to know range and domain, domain and range. You have to know the maximum possible number of x-intercepts. For each type of function. In behavior. So you have to be aware of the shapes of the graphs, which is the in behavior, of course, told to us by the leading coefficient of an equation. You need to know the y-intercepts, or the y-intercepts possible, how to find the y-intercept from the equation, which is from the constant term, and the number of possible turning points. So all these questions, all these possible characteristics could be asked from a linear graph, a quadratic graph, or a cubic graph, or even a constant.